We live in a world increasingly reliant on technology. Our smartphones, Wi-Fi routers, and even microwave ovens all emit a form of energy called radio-frequency electromagnetic fields, or RF-EMF. This energy is part of the electromagnetic spectrum, which includes visible light and X-rays. Unlike X-rays, however, RF-EMF is a type of non-ionizing radiation. This means it doesn't have enough energy to break chemical bonds in our bodies. While RF-EMF doesn't possess the same immediate dangers as ionizing radiation, its potential long-term health effects have been the subject of much research and debate. Specifically, scientists have been investigating whether prolonged exposure to RF-EMF from everyday devices could increase the risk of certain cancers. This is a complex question with no easy answers, but understanding the science behind RF-EMF is crucial for making informed decisions about our technology use. In the following sections, we will delve deeper into the sources of RF-EMF, how our bodies interact with this energy, and what the latest scientific research tells us about its potential health risks. We will also explore practical steps you can take to minimize your exposure to RF-EMF, while still enjoying the benefits of modern technology. Ultimately, the goal is to empower you with the knowledge you need to navigate this rapidly evolving technological landscape and make choices that prioritize your health and well-being. RF-EMF is all around us, emanating from a wide range of sources. These sources can be broadly categorized into three groups: personal devices, occupational sources, and environmental sources are the most common sources of RF-EMF exposure for most people. This category includes smartphones, tablets, laptops, Wi-Fi routers, Bluetooth devices, cordless phones, and microwave ovens. The amount of RF-EMF emitted varies depending on the device, its model, and how it's used. Of RF-EMF are typically encountered in specific workplaces. These include radio and television broadcasting antennas, radar systems, industrial heating equipment, and medical imaging devices like MRI machines. Workers in these settings may be exposed to higher levels of RF-EMF and require specific safety protocols. Encompass RF-EMF emitted from infrastructure and technologies in our surroundings. Examples include cell phone towers, radio and television broadcast towers, power lines, and electrical substations. The strength of RF-EMF from these sources generally decreases significantly with distance. Understanding the different sources of RF-EMF and their relative contributions to our overall exposure is the first step in assessing potential risks and taking appropriate precautions. When we use devices that emit RF-EMF, our bodies can absorb some of this energy. The amount absorbed depends on factors like the frequency of the RF-EMF, the distance from the source, and the duration of exposure. Our bodies absorb RF-EMF primarily as heat. This heating effect is most pronounced at higher frequencies, such as those used by microwave ovens. However, the levels of RF-EMF emitted by mobile phones and other common devices are far lower than those produced by microwave ovens. The heating effect of RF-EMF is the primary mechanism by which it interacts with biological tissues. While our bodies have natural mechanisms for regulating temperature, prolonged exposure to high levels of RF-EMF could potentially overwhelm these mechanisms and lead to tissue damage. However, it's important to emphasize that the levels of RF-EMF emitted by everyday devices are generally considered too low to cause significant heating effects. Section 4: Dose matters, device usage and exposure levels. The level of RF-EMF exposure from a device depends on several factors, including the device's power output, the distance from the device, and the duration of use. Power output. Different devices emit different levels of RF-EMF. For example, smartphones generally emit more RF-EMF than Bluetooth headsets. Distance RF-EMF exposure decreases rapidly with distance from the source. Holding a phone a few inches from your head exposes you to much higher levels of RF-EMF than using a speakerphone or headset. Duration of use. The longer you use a device that emits RF-EMF, the greater your cumulative exposure. Making short calls and limiting overall screen time can help reduce exposure. Understanding these factors can help you make informed choices about your device usage and minimize your potential exposure to RF-EMF. Section 5. The Cancer Question. Studies on RF-EMF and tumors. The potential link between RF-EMF exposure and cancer, particularly brain tumors, has been a subject of intense research and public concern. Numerous epidemiological studies have investigated this association with mixed results. Some studies have shown a possible link between heavy mobile phone use and an increased risk of certain types of brain tumors, such as gliomas and acoustic neuromas. However, other studies have found no such association. One of the largest and most comprehensive studies to date, the Interphone study, involved researchers from 13 countries and examined the mobile phone use of thousands of individuals with and without brain tumors. The study found no overall increased risk of brain tumors with mobile phone use. However, it did suggest a possible increased risk of glioma in the highest category of phone use, although the researchers acknowledged that this finding could have been due to chance or bias. The results of these studies highlight the complexity of this issue and the need for further research to clarify the potential link between RF-EMF exposure and cancer risk.